Okay, doing LC4. So, so this is a multivariable problem, and we're going to try to actually find a value of delta. And we have the lucky break here that this function is a very nice function. It's not as nice as it could. I mean, x squared plus y squared is really nice. X squared plus y to the fourth is not so bad, really. So here's the picture. We're talking about as we approach the origin. So our a is the origin, and the value of the function there, of course, is 0. Okay, this is let's see, this is the xy plane, and we're trying to show that the limit as we approach the origin is equal to 0, and we have an epsilon given as 1/4. So we're going to look around there. Epsilon equal to 1/4, and I want to know what's the corresponding value of delta. So what's the sort of the largest delta that can work? And again, I for sure I could take a teensy, I could let delta be 1/1000th, and clearly that's going to work because all the values that are super close to the origin are going to have values of the function that really, I mean, look at the function, it's going to be super close to 0, and that would definitely be within this interval. But I want to know what's the sort of the sort of the limit, what's the boundary case, what's the cutoff value. So let me write this down now. I'm looking for a delta here. And I want the following. I want to know that when the magnitude of x minus a is of course the 0 vector, when that's less than delta, I want that to imply that the absolute value of f of x minus L, of course L is 0, we're trying to prove that the limit is 0, is less than epsilon, which is 1/4. In other words, I want when the square root of x squared plus y squared is less than delta, I want that to imply that the absolute value of f of x, namely x squared plus y to the fourth, is less than 1/4. So this is what I want to do. I'm going to figure out what delta is going to make this work. Okay, so now let's look at the hint for the problem. The problem says, make use of the fact that for small numbers, fourth powers are less than squares. So there's only one fourth power in the problem. That's right here. So I want to try to make use of the fact that this fourth power I'm interested in is less than a square of something. So in particular, I know that x squared plus y to the fourth is going to be less than x squared plus y squared. Okay, does that make sense, everybody? Okay, so okay, go ahead. Yeah.
How'd you get the square root of x squared plus y squared?
So the square root of x squared plus y squared is the magnitude of this x vector. So I'm going to pick some x vector there. That's x, and it has coordinates x comma y.
Oh.
Yeah. Okay. So I know this. Okay, all right. So we'll fine then. So how about this? How about we do this? So let's try the following. Let's make square root of x squared plus y squared less than delta. Let's make that imply that x squared plus y squared is less than 1/4. Let's make that be true. If this implies x squared plus y squared is less than 1/4, then certainly we also have x squared plus y to the fourth is less than 1/4. Does everybody buy that? Because I mean, this is smaller than that. So if this is less than 1/4, then certainly that's less than 1/4. Is that cool? Okay. All right. So alrighty. Now, how can I do this? I mean, how can I accomplish that there. Oh, well, the algebra is looking really good at this point. Now let's see here. So I could take the square root of both sides of this, or I could square both sides of that, whichever you want to do. Maybe I'll take the square root of both sides of this thing here. We're going to try to make square root of x squared plus y squared less than delta. We're going to try to make that imply that the square root of x squared plus y squared is less than square root of a fourth, which is a half. If I can make this happen, then I feel like I'm in good shape, because if this value of delta makes that happen, well, that's identical to this, and that certainly implies this, because this number is smaller, and that's what I really needed. And so, okay, this is an easy one. What value do I have to make sure this radical is less than to make sure that that radical is less than a half? Well, the half, right, is really the only option. Does everybody buy that?
Sorry, I can't really see the last part.
Oh, I'm sorry. Is it too small?
Yeah. So is that a half on the last?
That's a half.
Okay.
Yeah, I'm a little sloppy with my twos these days. I should be more careful with that. Yeah. So I'm going to choose delta equal to a half, and then I get to demonstrate that this really does work, and this does solve my problem, because when maybe I'll use some new paper here. If delta is equal to a half, then if the absolute value, if the length of x minus a is less than that chosen delta of a half, well, that implies that square root of x squared plus y squared is less than a half, and that implies that x squared plus y squared is less than a fourth, and that implies that the smaller expression x squared plus y to the fourth is less than a fourth. But this is exactly the absolute value of f of x minus L, namely 0, and this was the epsilon that was given to me. So that really does imply that as needed, and so delta equals a half works. And that's the biggest value of delta that you can pick. Yes.
Can you please move the...
Oh, back this way?
Right.
Yeah.
How did you get D to...
How did I choose this?
You chose D to be equal to a half.
Yeah. So I mean, this is just it's just an observation that this inequality looks exactly like that inequality. And then so here's the thing: if you're going to put a limit, if you can require this expression to be less than some number of your choosing, and you need for that number to be less than a half, what do you want to require it to be less than? If you want it to be less than a half, well, how about I require it to be less than a half? Then it'll definitely be less than a half. If I make this a half, then this implies this statement because they're identical statements. Does that make sense?
Yes. Did you get the statement on the right hand? Did you get that? Is that the equation of the
So this came from here. So the idea was, now we're trying to take advantage of this hint here, that the fourth power is smaller than the square. So I figure, look, if I can make this be true, then certainly that'll be true. So this I can make true just by making that true. And that's why I'm trying to imply that so that I can conclude that, which will allow me to conclude this, which is what I really needed.
Right, but
Yeah.
okay, so if you say x squared plus y to the fourth is less than that, then doesn't that mean if you say x squared plus y squared should be greater than 1 over 4 instead of being less, because...
So I'm not trying, you're right that this does not imply that. This expression is bigger and this expression here is smaller. So I figure if I can show that this is true, let me do it like this.
Oh, right.
If I can show that this is smaller than a fourth, then certainly this smaller thing is also smaller than a fourth. Yeah, exactly. Okay? Everybody buy it? Okay.
Is that always a safe thing to do?
Well, it's true when you have small numbers, right? So when you have, so as the hint wrote, when you have small numbers, namely numbers whose absolute value is less than 1, then a to the fourth is less than a squared. This is just a property of small numbers. It's not true for every number. 10 certainly doesn't work, right? 10 to the fourth is way bigger than 10 squared. Right? But for small numbers, it is true. Yeah. Yep. Okay. So let me stop the recording on this one.